Okay, here today's session is bonding in Linux Red Hat version 6. This is also called channel bonding, NIC bonding, like that. We're having different names. Okay, so how first of all, what is a bonding in Red Hat Linux and how to do that? Okay, a NIC card is network interface control card is nothing but it is a neck card. What is the duty of this neck card is it is an ethernet card LAN. So if you have that card, then only you can access and you can connect the system or server to network. Okay, through that the server or the system will interact with the network. So that is the interface card. It is a hardware. It is it is just like it is a resource, just like hard drive, like that. NIC card is also a physical card. Okay, so the main purpose of it will act as interface between network and our server. Okay, so you know how to see how many NIC cards are there in Red Hat Linux. By using ifconfig command, you can see how many number of Ethernet cards are there. We'll call it as Ethernet card also. Okay, so uh, here a concept in Red Hat Linux is there, that is bonding concept. So what is the bonding concept is channel bonding. It is also called channel bonding. It enables two or more network interfaces to act as one, simultaneously increasing the bandwidth and providing the redundancy. Means sometimes if you work with only one NIC card, if the server is up on only one NIC card, that means if your server is connected to the network through only one NIC card, suppose if if that NIC card was down, what will happen? There's an interruption of service. Okay, that means your server will disconnect from that network. Simple thing. Okay, so it will be if it is down. Okay, so that means the availability of the server and the network was failed. Okay, so again you need to repair it, and you need to restore it. Okay, restore the net card. Okay, net card. And also if you for a high traffic networks, if you use only one net card, uh, that may be slow. Okay, you will interact with other systems in the network. The interaction will be somewhat slower, and the bandwidth is slower. Okay, or sometimes if there is a fault on that neck card, if it is down, there may be service interruption. That is also not desirable in IT industries. Okay, they need continuity of service. Okay, in such case there is a solution for all these things. So that is in real time it is called fault tolerance and also load balancing. Okay, so this bonding provides these two, fault tolerance and load balancing. So what this bonding facility is available in Red Hat Linux. What it will do is it enables two or more, okay, NIC cards to act as a one. That means it will bond. The name itself indicates that bond. It will bond two or more NIC cards. Okay, so that we can increase the bandwidth. Okay, bandwidth, and also it will provide the redundancy and fault tolerance. Okay, so how it was useful means if one physical NIC card is down, or sometimes if it is unplugged, it will automatically move resource to other NIC card. Okay, so that you will get high availability. Okay, that means the interruption can be overcome. Okay, without interruption the server will be up. Okay, always up. Okay, uh, and this channel bonding, here I am telling in terms of physical NIC cards. How this will be done in done by OS is, in the kernel there is a driver, bonding driver is there. Using that, by using that bonding driver, kernel will do that. That means on software side, simple terms, that means kernel means it is on software side. Okay, if it is on software side, kernel will OS side, that means on OS side there is a driver, it will handle the bonding. Okay, so physically we will bond. To support that bonding, you must have driver in kernel driver, driver, it is a module, kernel module, which support that bonding, then only that is possible. Okay, so if you look here, Ethernet cards, how in RHL6 the Ethernet cards will be, the naming convention will be ETH0, ETH1, ETH2. If there are 4 NIC cards or 4 Ethernet cards are there, they'll be called like this. They will be their representation is like this: ETH0, ETH1, ETH2, ETH3, like that. Okay, so bonding means we will simply combine these two, which acts as a single NIC card, that is called a bond0. You can do the same for another. You can do number of bondings in a system. Okay, so we'll see how to do that bonding in RHL6. Okay, so it is called bonding in RHL6. There is a different procedure in RHL7, that is called teaming. Okay, first we'll see it in 6 later, and in another session we'll see that in RHL7. Okay, first what we need to do is, you must create a master bond0 interface. That means here what we are doing is, we are combining, we are bonding two NIC cards as a single NIC card. So sorry, as a single bond, we are bonding it. That means bonding, that bonding is named as some bond0 or bond1, like that. So this bond0 acts as master, these two cards will act as a slaves. We will configure in that way. So this bond0 we will treat it as a single NIC card, but in that NIC card we are having a group of 2 NIC cards. Okay, so it will tell what you need to do. Okay, so that bond0 acts as a master and these two acts as a slaves. Okay, so first what you need to do is, the configuration files for these NIC cards will be in the /etc sysconfig. Okay, /etc sysconfig network -scripts. In that directory we are having all the configuration files. So here treat bond0 as a NIC card file. Okay, NIC card, so some NIC card. So for that we need to create a file. So the file naming convention for a Ethernet card or NIC card will be like ifcfg-eth0, ifcfg-eth1, like that. Here I am creating that for bond0 na. So for that I'm creating a file in this directory, that is /etc sysconfig /network-scripts. In that I'm creating a file with the name bond0, that is ifcfg-bond0. So edit the parameters in that file. So if you create a fresh file, then give the entries like this. So if is already file existing some parameters there, edit that one. So what are the parameters you need to edit mainly? Okay, how that inside that, what are the parameters in that file. So first one is a device. So on the left hand side of equal to, all the letters is in capitals only. You must remember that one. Okay, all must be in capitals. Okay, so here first one is device. In that you can have lot of entries. The main entries I am telling here. Okay, I'm giving the main entries. Okay, so the first field in that file is device. So device is equal to, first entry is device equal to bond0. You must give like that. So if it is a normal NIC card, you need to give like ETH0, ETH1, like that. That means this entry will be the name of that Ethernet card. but here we are doing a concept bonding. So first in this file you need to give that bond 0. So if it is the first bonding, you will give like that bond 0. You are having multiple number of bondings of bond 1, bond 2, bond 0. You can create a number of bondings there. So I'm giving bond 0. Next thing you must remember is IP address. Okay, IPADDR. So if it is IPv4 format, so you must give like this, capital letters IPADDR, capital letters equal to, you need to give that IP address. Already you will have some IP addresses there. What address you want to assign, you will assign there. Okay. Next thing is NETMASK. So NETMASK, you need to give the entries here. Next, user control, no option. Okay, on boot, yes. So what this will do is, on booting, again it will after rebooting it will reflect the same changes. That means giving the entries in this file will keep permanently, it will save all these settings. If you give on boot here, yes, after rebooting only this will restore this configuration. If you don't give here yes, if you give no here, then if you don't give any entries, or if you give no here, it will treat as it will doesn't restore these settings after the next reboot. Next, BOOTPROTO. So what this BOOTPROTO means, there are two ways of assigning the IPs in Linux. The first way is static way of assigning IP address. Second way is dynamic way of assigning addresses. Static way means simple this way. That means we are having some IP address by giving this entry here in this entry, and also by using temporarily we can give that using ifconfig eth0 up the IP address and up. In those two ways we can give that static IP address. So that will be permanently assigned that IP address. Whereas the second way is dynamic addressing there. So if static address is assigned, that means you need to give none here. BOOTPROTO is none. Boot protocol. So if BOOTPROTO is equal to DHCP, dynamic host configuration protocol. So if you assign DHCP here, that is called dynamic protocol. That means there is a DHCP server there that will assign all the IP addresses by itself. There is some settings inside that DHCP server. Based on that, it will dynamically allocate the IP address. There is some time every IP for every system, some IP is assigned for some lease time. Based on that, DHCP will do that. Okay, after some time that IP may change. That means we don't get the same IP every time in DHCP. Of course we can do that by changing some settings in DHCP, but after rebooting again the IP will change. So if you give DHCP here, this IP address will change time to time. That means DHCP will take care of assigning all the IPs. Whereas static way means we will manually configure that IP address. Okay. So there are two types, static and dynamic. So static means we need to assign the IP address in simple terms, and dynamic means the DHCP server will take care of it. DHCP will assign the IP addresses. So but in real time almost IP addresses allocation will be done in static way. Okay, of course DHCP also there. Many environments will do like that. So here I am at assigning the IP address. So what I need to do is I need to keep this BOOTPROTO as none. Okay, if you don't keep it none, so this IP address will be overwrite by that DHCP. Okay, you must do that. Okay, DHCP. Next thing, last one is this. Of course we are having some more entries here, but in this context those are not that much required. So bonding -OPTS. Okay, in some other session we will talk about the other options. Okay, so here bonding options, there are some bonding options available. We can configure bonding in different modes. Okay, so based on the modes, which mode we want to select, we need to give the options here, bonding options. That is mode 0. You're having 7 modes. Mode here I am taking mode 0, and you're giving giving this sometime 100 milliseconds I am giving for this I will tell what is this 100 seconds. You're having two neck cards now. If one neck card is down, the other neck card will be up. How much time you are giving to the other neck card to take over? That is this thing, MIMON. So these are the main entries. Okay. One more entry here is gateway also. Gateway, if it is in same network, no need of giving gateway. If it is that means gateway means configuring a router. That's also will be discussed in some other session. I'm not going thoroughly about that concept. Okay, we'll discuss in some other session. Okay, so in this file ifcfg-bond0 file, you need to give like this. Okay, next, that is the first step. So I told you here the bonding options are there are some modes are there na? These are the modes. There are totally 7 modes are there. So if you give mode equal to 0, then that is round robin configuration. Round robin mode. Okay, what is that round robin mode? So here the packets are the packets are transmitted sequentially, received sequentially through the interface one by one. Okay, that means round robin. You know round robin game. Round robin game. That means here we are having, suppose let us consider 2 neck cards. Okay, the traffic of that the packet traffic transmission will be handled alternately by one. So first one neck card, after that next neck card, first other neck card, one by one they will handle all the traffic. That is called round robin. If you consider mode 0, that is called mode RR or round robin. The second mode is mode 1. That is also called active backup. One neck active while another neck card is asleep. If the active neck goes down, then another will take over. Okay, it will support in x86. Okay, next there are other modes also there. I am not going through it. Okay, have a look later. Okay, now I am configuring this in this 0. Okay, these are based on the environment, they will choose these modes. Okay, here our system admin is just we need to consider which mode. That's enough. Okay, if you want to know it, do some research on it. Okay, that's about. Okay, that's the first thing. What we need to do, the very first thing, we need to give the interest in this. You need to create a file with ifcfg-bond0 in this configuration, in this directory, that is /etc sysconfig network-script. Okay, in that you need to give the entries like this for bond0. Here we are stating bond0 as a device. Of course it is a concept, but we are treating bond0 as a device. So what is this bond0 means? It is bonding two neck cards, ETH0 and ETH1. Let us consider. So but we are treating this bond0 as a master. Okay, for that we need to give the entries like this. Okay, these are general entries that we will configure for a neck card. Okay, next, the next thing is we're having two neck cards. Sorry, here the entry was given EM. Okay, ETH not. Okay, so next thing what you need to do is we need to configure the ETH not ETH1 neck cards also. Okay, now so again the file we're having that files in /etc sysconfig network-scripts. We need to create a file with the name. If the file is existed there, no need to worry. You modify that thing. If it is not existed there, you need to create a new one. So the name will be like this: ifcfg-eth0. That is the first neck card. So here you need to give is device equal to eth0, BOOTPROTO none. So we are not opting any DHCP. We are assigning it DHCP static way of assigning IP. ONBOOT yes. Master, these two entries must. Master equal to bond0. So for this it is acting, ETH not acting as a slave. What is controlling it? It says bond0. Master equal to bond0. Slave equal to yes. Slave equal to yes means this is acting as a slave. Bond is acting as a master. Okay, next we're having one more NIC card, so we need to bond these two now. The second NIC card also we need to configure in the same way. ifcfg-eth1, sorry, here em1 is given, eth1. Generally here RHL6 the naming convention will be eth0, eth1, like that, eth1. So again device name is eth1, BOOTPROTO none, unboot yes, master equal to bond, slave equal to yes. Okay, that is the second step. So first step is the master is bond0. You need to configure, you need to create a master bond0 interface file. You need to give the entries here, like that. Second thing is you need to configure the slave interfaces. Okay, slave interfaces like this, ifcfg-eth0, ifcfg-eth1. In that these two entries must be given. Okay, next the step is you need to configure the bonding driver. Bonding driver means it is just a module in kernel. It is handled by kernel. It is a driver means it is a software. You must configure it. The configuration, you must change the configuration in that file. So the configuration file for bonding is /etc modprobe.conf. Okay, but we need to do a change in this configuration file, that is /etc modprobe.d and /bond.conf. You need to give entry in this file. Which file it is? /etc modprobe.d /bond.conf. In that file, what you need to give is alias bond0 equal to bonding. So bonding is a driver in Red Hat Linux. So just like it will consider it as some command. So what alias will do is, by using alias we can change the name, change the command structure. That means if ls is there, we can change ls to, every time we are executing ls, if execute ls, then it will give some outputs now. So if there is a lengthy command is there, suppose ifconfig command is there, I don't want to type all that command every time. Just simply I want to change it to 3 words. Suppose ifc, just ifg, I want to give it as ifg. So there you can change it alias ifc ifconfig. Then automatically if you execute ifg, the kernel will treat it as ifconfig. So alias command will work like that. So here what alias is doing, bond0 is created by ourselves, but the bond0 will treat as bonding. So whenever kernel sees bond0, it will treat it as bonding. Okay, that means it is bonding some devices. What are those devices? Means already we have configured 2 devices are there, eth0 and eth1. So you must give the entry here, then only it will be configured. Where you need to give these entries are /etc modprobe.d /bond.conf. okay, you need to create this file. Okay, next after that what you need to do is you need to restart the network. Okay, why we need to restart the network means it has to, we have modified the configuration now. Okay, that means it has to resemble that changes. Okay, for that we need to restart that network service. Here the network, what is this network service means, is it is just like a daemon. Okay, it will take care of network. If this network service run, then only the server will interface with the other servers within the network, then only that will run. Just like it is a daemon, if SSHD will run, then only SSH will work in that system. In the same way, network is a service. So how to restart network services? By using service command you can do it. Okay, and the next reboot, if you want to persist, then you want to do it permanently, then you by using check config. Okay, in RHL6 we can do that by using service command. Okay, by using service network we can do that. Okay, service network restart. Okay, so in case if you don't want to restart the network circuit, you want to do it bonding interface individually, just you can do by using this ifcfg bond0. So it is just like ifcfg means ifconfig eth not up, just like that it will work. That means it will up bond0, that will give the. Okay, so next check whether the bonding is verified by using this ifconfig-bond0, then you'll okay, we'll see how it will. Like if you want to verify whether the bonding module is loaded properly or not, okay, by using this command lsmod. So lsmod means this command will give the what are the modules handled by kernel. Okay, you are grepping it bond0. Bonding is a module. Okay, this. So if you want to see which device is active, there you can use this cat this file. If you look into this file by using cat, there is proc/net bonding bond0 file. There you will see which device is active. Okay, we'll see one by one all those things. Okay, we'll do some practice session there. You'll get everything, you'll understand everything. First thing is you must verify how many NIC cards in your system. Here it is a practice session. So at the starting, after creating VM, you will have only one NIC card in your system. Okay, so how to see which NIC, how many NIC cards are there? By using ifconfig command. If you give the command like this, ifconfig command, there you will find like this devices ETH0, ETH1, like that. So that means we're having two NIC cards here, and otherwise the loop interface, it is, you know, what is the thing is. Okay, so I'm having two NIC cards, so bonding is possible. If you're having two NIC cards, two or more NIC cards, then only bonding is possible. If you don't have two NIC cards, that bonding is not possible. So it is another machine, another VM. Here I'm having only one NIC card, ETH not only. So how to add that another NIC card in VMware? So I'm just showing it, this one. So how to do that one is go to settings. In VM you will find the field settings. There you will have all the resource group here, resources, there network adapter, there NAT. So you need to add it. Okay, so network adapter and next. Okay, finish. Okay, I'm not doing that because it needs restart. Okay, so that will take some delay. Okay, so already I have in another VM, already I am having two NIC cards. I will show you here only. Okay, but here if you want to add it, go to, if you want to add one more NIC card for any VMware machine, go to settings. Once again I'm showing it, network adapter, add. Okay, network adapter, next, like that. Okay, simple thing. And after that you need to restart that your machine, then only the change will reflect, otherwise it will not reflect. Here I have already done that process. Okay, so bonding, you must do the bonding as a root user, because here I am logged in as a yogi. So su iPhone, I'm switching as a root user now. Okay, first step what you need to do is go to one by one, step one. Okay, so first you need to create a master bond0 interface file in this configuration file. What is that one? /etc sysconfig/network-script. Okay, so you can do that in two ways. One way is just by moving to that /etc network-scripts file, sysconfig /etc sysconfig network-scripts file. Later there you can create that file, or you can directly create a file like this, vi /etc sysconfig network scripts. Okay, you can do that also, but I want to show what are the files there. Just I can move to that directory. Okay, so I want to show what are the files generally there. Okay, ls command. So I'm having this file. This file is for first NIC card. Okay, This is for loop interface. Just now I have added ETH1. I haven't configured ETH1 file. That's why it is like that only. Okay. Next, there are different files, if up, if down. Okay, based on these files, the interface neck cards will up and down. Okay, there are the different configuration files are there, routing. Okay, if up, if down. Okay, so just look into that ifcfg eth node eth configuration file. So look here, device eth node hardware address. This is MAC address, you know. So for bonding, you know, no need of giving MAC address. Of course, even though if you don't give it, it will all, because you are bonding two NIC cards now. Two physical cards are bonding. Virtually, you are bonding it. So it will take any one of the NIC card MAC address. Either it is ETH01 or ETH1. Okay. So device ETH0 and HWR address. Type is Ethernet. Okay, you are having lot of entries here, but no need of all those things. Okay, you want to configure it, but for our concept I am giving only the required entries only. You will have in real time all these entries. Okay, here one more entry, this one nm underscore control equal to 0. So nm means network manager. You must keep this as no. Okay, nm underscore control equal to no is there now. So you must give this as no. If you give here yes, network manager will see all the controls, all the, it will manage all the things. Okay, so while doing this bonding you must keep it as no, or you can do that in another way also, by service command, service network manager stop. Okay, that also you must do. So first check whether network manager is running or not. Of course it is not running because I have given the entry here no. If it is running, let us check, because it was a permanent entry. After reboot only it will reflect. If it is not so, you must do it. Okay, network manager, just see the network. In network, n must be capital, m manager, m must be capital. Just check the status before doing the bonding. You must check the status of network. Yes, it is running, so you must stop it. If no, if don't, then what will happen is it doesn't allow that bonding. Okay, so you must stop it. And one more thing, you can't configure this bonding using putty. Why? Because putty will connect through SSH. That means if the network is up, then only putty will work. Putty will, it is a third party software through SSH. Okay, from other systems, from a system we're connecting to the server. We are having a third party. Okay, if the network was down, that means there is no network between the server and this system where putty was installed. Then putty will not interact with the server now. So don't configure network related things through putty. You cannot configure it. Okay, you must do that, because while this network manager was stopped, network was stopped, that thing was not reflected. Okay, so putty will not interact with the server. Putty will interact the server through network only. If network was stopped, putty cannot connect through this net server now. So we cannot do that putty. You need to do that by terminal only, console only. Okay, so what you need to do is you need to create a file, vi ifcfg-bond0. So the entries, what are the entries we are having? First one is a device. So the entries on the left hand side must be in capital letters. Here the device name is bond0. Okay, second entry is, of course we can give in any order. Okay, IPADDR. No, it's, I think, okay, I will verify it. Sorry. Okay, bond0, sorry. IPADDR equal to IP address, that is IP address. Which IP address you want to assign it? 192.168.1.1. 168 I think it is 61.129 and give the NETMASK also. NETMASK, okay, 255. You need to calculate in prior all these things. Okay, 0. You can all add gateway also. Here I am taking the gateway. I'll tell this gateway concept later. Networking related concept. Okay, I'm giving this gateway as 192.168.61 dot the first consider that first one as the gateway router. Okay, router gateway configuration. Next entries what you need you give that one is these three are over. User control equal to no, ONBOOT yes, BOOTPROTO none. This last one is important. Okay, so user control ONBOOT, USRCTL equal to, I think it was no. Of course this nothing change, will small letters no. User control no. Next BOOTPROTO must be none. Next bonding options, so must give the entries like this only. If there is some spelling mistake over this, that doesn't work. Bonding hyphen options, sorry, bonding hyphen opts is equal to, here what you need to give is you need to specify the mode equal to 0 comma space, again I am giving space miimon equal to, you need to give some 100 milliseconds time.
యూజర్ స్పెల్లింగ్ కూడా అక్కడ యూఎస్
that was mistake. నేను ఇక్కడ కరెక్ట్ చేశాను. That's not a problem. Okay, after that you need to save it. Of course you're having some more entries, but these are the main entries we need to remember. Warning OPT is equal, mode equal to 0, miimon equal to 100. Okay, there is a time we are giving to change over between NIC card 1 to NIC card 2 with whenever fault occurs or some fault tolerance. Okay, 100 millisecond we can change it. Okay, based on our requirement we will do that. Okay, so next save it, escape shift WQ. If there is any wrong entry you will find it later. Okay, next